A single AI agent is impressive. It answers questions, writes code, searches the web. But what happens when the task is too complex, too long, or needs multiple specializations at once? That's when you stop thinking about agents and start thinking about agent systems. Hey, welcome to AmTalk Soft. Today we're going deep on multi-agent AI systems, what they are, the patterns that actually work in production, and the real frameworks developers are using right now: LangGraph, CrewAI, and AutoGen. I'm going to skip the hype. We'll cover why single agents fail at scale, the 3 orchestration patterns you'll see repeatedly, and the production pitfalls that aren't in any tutorial. Let's go. Here's the core problem with a single LLM agent: context windows. Every agent has a maximum number of tokens it can hold in memory at once. Even with Gemini 2.5 Pro's 1 million token context, that context fills fast when you're doing real work, reading source code, calling APIs, iterating on output. But context window size isn't the only constraint. Specialization matters. An agent optimized for generating Python code isn't optimized for writing documentation or running security audits. Asking one agent to do everything degrades the quality of everything. Speed is another wall. A single agent works sequentially: step 1, step 2, step 3. If those steps are independent, you're wasting time. Finally, reliability. A single agent that fails at step 7 of a 10-step task means starting over. Multi-agent systems can isolate failures. One subagent fails, the orchestrator reassigns or retries, and the overall task continues. There are 3 architectural patterns that show up repeatedly in production multi-agent systems. Pattern 1, the pipeline. Agents work in sequence, each passing output to the next. A research agent finds sources, a writer agent drafts, an editor agent polishes, a fact-checker agent verifies. Each specializes in one stage. This is the easiest to reason about and the easiest to debug. Pattern 2, the orchestrator-worker. A central orchestrator agent breaks down a task and delegates subtasks to specialist worker agents. Workers report back, the orchestrator synthesizes. This is the model CrewAI popularized. You define a crew with roles and a process, and the orchestrator handles coordination. LangGraph implements this as a state graph. Each node is an agent, and edges are the flow of state between them. Pattern 3, peer-to-peer. Agents collaborate as equals, negotiating and reviewing each other's work. AutoGen's multi-agent conversations work this way. 2 agents debate, critique, and refine output until they converge. It's the most flexible pattern and the hardest to control. In practice, most production systems combine patterns: a pipeline of orchestrators, each with their own worker pools. That's what you see in enterprise coding agents and autonomous research tools. Let's talk tools. The 3 frameworks dominating multi-agent development right now are LangGraph, CrewAI, and AutoGen. LangGraph from the LangChain team models agent workflows as directed graphs. Nodes are functions or agents. Edges define conditional flow. Agent A calls a tool, checks a condition, routes to agent B or C. Crucially, LangGraph manages state. You define a state schema, and every node can read and write to it. This makes it the right choice when you need fine-grained control over agent behavior and human-in-the-loop checkpoints. CrewAI abstracts higher. You define agents with roles, backstories, and tools, then define tasks. CrewAI handles orchestration, sequential, hierarchical, or parallel process modes. It's faster to prototype but less transparent about what's happening internally. Good for content pipelines and research automation. AutoGen from Microsoft is built around agent conversations. You define agents that can initiate, respond to, and terminate conversations. The strength is code execution. AutoGen agents can write and run code in sandboxed environments, check results, and iterate. It's the right choice when your workflow involves running code as part of the loop. None of these frameworks is universally better. The right tool depends on whether you need control, speed to prototype, or code execution capability. Here's a concrete example of a multi-agent system in production, an automated research and writing pipeline. Stage 1, an orchestrator receives a topic. It spawns 3 parallel research agents. One searches academic papers via Semantic Scholar, one scrapes recent news, one queries an internal knowledge base. Stage 2, a synthesis agent reads all 3 outputs, identifies contradictions, and produces a structured outline. Stage 3, a writing agent drafts each section of the outline in parallel, 1 section per worker. Stage 4, a critic agent reviews each section, scoring it for accuracy and clarity. Sections that score below threshold go back to the writer. Stage 5, an editor agent assembles the reviewed sections into a final document. Total wall clock time, 4 minutes for a 3,000-word research document. A single sequential agent doing the same task takes 18 minutes and produces lower quality output because it can't specialize. Multi-agent systems sound appealing, but they come with real costs. Cost blow-up. Every agent call is an LLM API call. An orchestrator spawning 10 workers that each make 5 calls means 50 LLM requests per task. At sonnet-level pricing, a complex workflow can cost dollars per run. Profile your agent graph before going to production. Debugging complexity. When a single agent fails, you read its trace. When an orchestrator-worker system produces garbage output, tracing which worker caused it and what state was passed requires proper observability tooling. LangSmith, Arise Phoenix, and OpenTelemetry integration are non-optional in production. Latency. Parallelism helps, but agent coordination adds overhead. If your task completes in under 30 seconds with a single agent, a multi-agent architecture will likely be slower, not faster. Use multi-agent systems when tasks are too long for one context, require specialization, or have genuinely parallel subtasks. For simple Q&A and short-form generation, a single agent is always better. Here's what to take away. Multi-agent systems solve the context, specialization, and parallelism limits of single agents. The 3 patterns, pipeline, orchestrator-worker, and peer-to-peer, cover most production use cases. LangGraph gives you control. CrewAI gives you speed to prototype. AutoGen gives you code execution. And before you build any of it, cost, observability, and latency are not afterthoughts. Build them in from day one. If you found this useful, subscribe for more deep dives on AI engineering. We cover real production patterns, not just tutorials. Next video, we're looking at how to add observability to your LangGraph agents so you can actually debug what went wrong. See you there.